We're going to be solving systems of equations by graphing. So there are three important things that you want to keep in mind throughout the lesson. You want to know when will you have only one solution, when will you have infinite solutions, which is many solutions, and when will you have no solutions at all. So I'm going to talk about that really quick, and then I'm going to show you some examples. So here are the key concepts. So this is an example of one solution. So if you have two lines right here, so one is a positive slope because the top is in a positive direction. This is positive to the right. And this slope is negative. So usually when you have a positive and negative slope, you're going to intersect at one solution. So this is the one solution right here where the lines intersect. When you're going to have infinite solutions, that means you have two different equations that have the same exact everything, the same exact y, the same exact slope, the same exact y-intercept. Since they're the same exact line, they're going to have many solutions that are the same, so that's where you will get infinite solutions. And then when you get no solutions at all, that's when your slopes are exactly the same, but your y-intercept is different. So where your line passed through the y-axis is going to be different in order for you to have no solutions. Same slope because you're rising and running at the same rate, but you have different y-intercepts. So let's say you have one higher and one lower. If they're rising and running at the same rate, that means they're never going to intersect, which means they will never have any of the same solutions. So I'm going to graph out the first one. So you want to make sure your equation is in y-intercept form. Now, right now we have equations, but then later in the lesson you'll move on to inequalities. It's the same kind of concept. So we have y equals negative x plus 9. So just some reminders. Y is going to be your y coordinate. X is going to be your x coordinate. Whatever is the coefficient of the variable x is going to be your slope. So in this case, since there is no number there, I'm going to put a 1. Remember, slope is going to be rise over run. So since I did not have a number in front of my variable x, my x coordinate, my coefficient, I didn't have a coefficient, I know that my slope is going to rise 1 and run 1. And my slope is a negative number because I have a negative sign. So I need to make sure the top of my line is pointing in the negative direction and not on the other side, which is pointing in the positive direction because my slope is negative. And then this 9 is going to be your y-intercept. And that's where your line passes through the y-axis right here. This is the y-axis. So the y-intercept is where your line passes through the y-axis. Once you have your equation in slope-intercept form, you can go ahead and graph it. So you want to start with the y-intercept. So my y-intercept is 9. So I know the line is going to pass through the y-axis at positive 9. So since it's positive, I'm going to start at my origin 0, 0, and I'm going to move up on the y-axis, and I'm going to plot my first point at 9. And then I'm going to use my slope to rise and run so I can get the rest of my line. So I'm going to rise 1 and run 1. Notice that the top of my line is in the negatives. It's pointing in a negative direction. And since I don't have more room to go higher on my graph, I'm going to go down and then go to the right. So I can go down and go to the right, go down 1, and then run 1. So remember, rise over run, and then you can go ahead and put your line. And this is not going to be a perfect line. Okay, and then you can put your arrows because remember, this is a constant function. It's going to keep going, so you want to put those arrows on the end. My next equation is y equals 3/5 times x plus 3. So I'm going to go ahead and graph that with purple. So you always want to start with your y-intercept if it's in slope-intercept form. I'm going to start with my y-intercept, which is 3. That's where the line needs to pass through the y-axis. So I'm going to start at my origin 0, 0, and I'm going to go up to positive 3. Since my y-intercept is positive, I know to move above 0 instead of below 0. And then I'm going to go to my slope, which is rise over run. And since my numerator is 3 and my denominator is 5, I'm going to be rising 3 and running. And since my slope is a positive number, I know the top of my line needs to face the right and not negative, which is the left. So I'm going to go up 1, 2, 3, which is my numerator, 3 right here. I'm going to rise 3, 1, 2, 3, and then I'm going to run 5. 1, 2, 3, 4, 5, and I'm going to put a point there. Notice that my slope is in the positive direction. This is positive direction. You want to go from the top to the bottom. I'll explain that in a second. All right, so I'm going to I have 2 points graph. I'm going to get a line, and then I'm going to put a line going from here to here, and then I'm just going to keep going. All right, and then I'm going to put my arrows on the end because the numbers are not going to stop. So this is going to be a positive slope. So if I were to do a vertical line test, you should have heard about that when you learned about functions, if you learned about that already. If I go from top to bottom here, notice that the top of my line, for the blue line, the top of my line is in the negative direction. It's pointing to negative. So this is negative and this is positive. So because the top of my line is negative, I know my slope is a negative number, which was the original that I graphed, y equals negative x plus 9. So I know that that slope is negative. And then if I look at the other one, so if I keep going down here, and I look at my other line, which is this line right here, my y equals 3/5 times x plus 3. The top of that line is right here, and it's pointing in the positive direction. So this slope is positive, and 3/5 is positive. Now, if you want to solve the system, you want to find out where do the lines intersect. So these lines intersect about right here. And then and based on that, you can get that order pair. So this order pair is in quadrant 1, and it looks like it's a little in front of 4. So my x coordinate, remember, is x comma y. So it looks like my x coordinate may be 3 8/10, and I have to rise about 5 3/10. So that will be the solution, the point which my lines intersect. And there's only one solution because these two lines only intersect at one point. How did I know there is going to be one solution? Because one of my slopes is positive and the other slope is negative. So I know that I would have had one solution without even graphing it, but that's just a quicker way for you to think about it, but you still want to know how to graph. Okay. So the next one we're going to see, when do you have infinite or many solutions? So I'm going to write my equation, which is y equals negative x plus 9, which I just had graphed. So I'm going to graph that back. So I'm going to start with my y-intercept. The y-intercept is positive 9, so I'm going to start at my origin 0, 0. So the line must pass through the y-axis at positive 9, so I went up. And then I have to rise 1 and run 1. My slope should be negative. So this is my line once again. All right. And then I'm going to go ahead and graph this other system right here, which says that 2 times y is equivalent to negative 2 times x plus 18. So I want to put this into slope-intercept form. Y equals mx plus b format. So that's the slope-intercept form. So the first thing I want to do is get my coefficient off of y. So since this says 2 times y, I want to get rid of the 2. So I want to undo multiplication, which is division. So I'm going to divide both sides of my equal sign. So remember, this is my equal sign. And whatever you do to one side of the equal sign, you want to make sure you do the same thing to the other side to maintain equivalency. So if I divide my right side by 2, I need to divide every term on my left side by 2 as well. So this 2 is going to cancel out. I'm going to bring down my y. I'm going to bring down my equal sign. And I have negative 2 times x divided by 2. Negative 2 divided by 2 is equal to negative 1. So I'm going to put negative 1 times x. The x is still there. And then I'm going to put plus, and then I have 18 divided by 2, which is 9. So if I graph that, which is the exact same equation that I started with, I will start at positive 9, which is here, and then I have to rise 1 and run 1 to the left, making sure my slope is negative. And notice that my line is on top of the line that I just wrote from the last equation. So because the equations have the exact same slope, the exact same y-intercept, they are the exact same equations once you solve them, then that tells you that there are infinite solutions. Why are they infinite? Because the lines literally are the same line. So they're going to have many solutions, infinite number of solutions, so many that you can't count them. Numbers never stop, so that's why this is infinite solutions, because the equations are exactly the same. So that's infinite solutions, when the equations are exactly the same. Now we're going to look at when do you have no solutions. So we already have our first equation graphed, y equals negative x plus 9. So we already have that graphed. And then we're going to graph y equals negative x plus negative 4. Let's say negative 4. And if I were to rewrite this, it'll just be y equals negative x minus 4. So my y-intercept in this case is negative 4. So that's where my line needs to pass through the y-axis, because that's what the y-intercept is. And remember, this is your y-axis right here. So I'm going to start at my origin 0, 0. I'm going to go down to negative 4. Remember, moving down is a negative situation. So I'm going to go down to negative 4, which is here. And then I'm going to use my slope, which is my rise over my run. Now, since there is no number in front of my x, the coefficient is 1. We should know that because x times a number, or x times 1, is still x. So I'm going to put 1, and I can change 1 into a fraction by putting it over 1. So whenever you have a whole number in front of as a coefficient being multiplied by x, you can put it over 1 so you know how many you're running. So now I have my slope. My slope is negative. So I'm going to rise 1 and run 1. Rise 1 and run 1. Rise 1 and run 1. And then I'm going to make my line. So the y-intercept is plus 9 on that equation. And then my y-intercept is plus 4 on the other equations, but they both have the same exact slope. The slope on both is negative x. So because the slopes are the same, they have the same slope and different y-intercepts, that means the lines will never run into each other because they're rising and running at the same rate. So the lines should be parallel. Because my lines have the same slope, right here you can see that these two lines have the same slope, and these should have the same slope, but I'm not perfect, so it kind of look a little off. We can conclude that the lines, or that these are parallel. So when we have the same slope but different y-intercepts, the lines will never run into each other, which means they're not gonna have any solutions. No solutions, because the lines are parallel. Okay, so we're gonna look at a couple of examples. So here's an example right here. Notice that our slopes are going in different directions. So if the slopes are going in different directions, they're going to eventually intersect at one point and have one solution. So if you look at this, the first equation, slope is negative 2. And remember, slope is rise over run. So if you want this to be a fraction, you can put it over 1. And the other equation have a slope of 5/10, which is 1/2. So because this slope is negative and this slope is positive, the two lines are eventually going to run in opposite directions. And like I said before, they're going to intersect at that one solution, and that's going to be the solution, the answer to the question. And that's how you will solve by graphing. All right, so we're going to graph this one. The first thing you want to do is make sure your equation is in slope-intercept form. So slope-intercept form is y equals mx plus b. Y equals mx plus b. So I'm going to write my first equation, which says 15 times x plus 5 times y equals 25. All right, so the first thing I want to do is get my y on one side of the equal sign by itself, preferably the left. So I'm going to subtract 15 from both sides because it's added to the other term. And I'm going to subtract 15 times x from the other side of the equal sign. So remember, to maintain equivalency, whatever you do to one side of the equal sign, you have to do the same thing to the other side. So this is going to equal 0. So basically it cancels out. And then I'm going to bring everything down. So I have plus 5 times y. I'm going to bring down my equal sign. And I'm going to switch this because I want my mx to be first. So I'm going to put negative 15 times x. And then since this 25, my constant, is positive, I'm going to put plus 25. Remember, a constant is the term that's going to stay the same no matter what. So now I need to get y by itself because I need y equals mx plus b, not 5 times y. Okay, so I'm going to, since it says 5 times y, in order to undo multiplication and in order to undo 5 times y, I need to divide by 5, and whatever you do to one side of the equal sign, you have to do the same exact thing to the other side. So I'm going to divide my terms on the other side by 5. And I'm not writing it twice. I'm just dividing all of my terms by 5. So remember, a term is separated by a plus or minus sign. So negative 15 times x needs to be divided by 5 because that's my first term on the right side. And then 25 needs to be divided by 5 because that's my second term on the right side. And if I had a third term, I would have to divide my third term by 5 as well. So I'm dividing my terms on the other side by 5. So this 5 times y divided by 5, that's going to cancel out because 5 divided by 5 equals 1. And 1 times y is just y. So I'm going to bring down my y. And then I'm going to bring down my equal sign. And then I have negative 15 times x divided by 5. So I know 15 divided by 5 is 3. And a negative divided by a positive is a negative. I need the opposite of 3, which is negative 3. And I'm going to bring my x here, all right? So if I have 15 x's and I divide them evenly into 5 groups, each group is going to have the opposite of 3 times x 3 times. Then I'm going to put my plus sign, and then I have 25 divided by 5, which is 5. Now I'm going to go ahead and graph that. Since it's in my slope-intercept form, y equals negative 3 times x plus 5 is equivalent to the original. So I'm going to start with my y-intercept. And that's where your line passes through the y-axis. So I'm going to start at my origin 0, 0. I'm going to go up to positive 5 since my constant is positive. And then I'm going to use my slope to graph my line. So slope is rise over run. So I need my slope to be negative. So I know the top of my line needs to point in a negative direction, which is over this way. So I'm going to start at my y-intercept, the point that I just made. And I'm going to rise 3, 1, 2, 3, and run 1. Now, why am I rising 3 and running 1? If I want to make 3 a fraction, I would just put it over 1. So once you have your coefficient as a fraction, you can rise and run. Okay? And then I want to go down 1, 2, 3, and run 1. So it doesn't matter as long as you go in the negative direction, everything will work out. I'm going to go ahead and graph my line. So I'm going to put my line going through my points that I made, trying to make it as straight as possible, going as far as I can, going through the points that I made. And then I'm going to put my arrows on the end because remember, this will not stop. And then I'm going to go ahead and graph my other one. Now my other equation is already in slope-intercept form. So I'm going to go ahead and graph it. Actually, it's not. I can switch around since it's in y equals, I have my constant and then I have my minus 3 times x. So I'm just going to rewrite that, and I can rewrite that as y equals, I'm going to move my negative 3 first because that's my slope, negative 3, and I'm going to multiply that by x. Now the sign that was negative is stayed in front of the slope. You cannot change the sign of the slope. The only way that the sign will change is if you're moving it from one side of the equal sign to the other. So because I'm not moving negative 3 times x to the other side of the equal sign, it's going to stay as a negative number. And then I'm going to move 5 over, and since that 5 was positive, I'm going to keep it as a positive number. Now, as a reminder, because I didn't move 5 to the other side of the equal sign, it's still a positive 5. And now I'm going to go ahead and graph that. So I'm going to start at my origin 0, 0. I'm going to go up to 5. So this is 4, this is 5 right here. And then I have to rise 3 and run, and my slope needs to be negative. 1, 2, 3, run 1. 1, 2, 3, run 1. So I can see, since my equations are exactly the same, that they're going to have infinite solutions. So this is going to be infinite solutions, because look at all of these solutions and the solutions that I cannot see. All of these solutions right here, all on the lines everywhere. They even go on forever, because remember, these arrows mean that this line goes forever with that same function. So if the equations are identical, that means you're going to have infinite solutions.